Okay, in this video we will do an example of approximating binomial probability by the normal curve. Okay, there you have the problem in question. You can pause this and read the problem. In case you're wondering what arctic tern is, there's a picture. Okay, basically what this is talking about is that we have this bird which migrates from summer nesting area to the winter feeding ground. Okay, and the chance of these birds surviving is 0.65. Okay, so they do have to fly long distances. Okay, and what they want to know is that they banded or attacked 500 of these birds during the summer nesting area, and want to know what is the probability that between 310 and 340 will survive, meaning that those number of so-called banded or attack will be found in the during the migration. Okay. All right, so let's go ahead and I think I can move this out and do our problem. Alright, so this problem amounts to computing what is the probability that we have between 310 and 340 that survives the journey. So x here represents the number of birds that survive the journey. Okay, before we proceed, let's go back and summarize some of the variables. Remember, 65% of the birds survive. That means that's our probability of success, the small p. Okay, that means q is automatically 0.35. Okay, and remember they banded the 500 birds, so that's the number of experiments or trials that they have done. Okay, and if you recall from this, we can find out what is so-called population mean. The formula is NP, so that is 500 times 0.65, and that should be, I zoomed this camera in so that everything's gonna look a little bit bigger than usual. So 500, turn it on, 500 times 0.65 is equal to 325. Okay, and then put that 0.0 just so that I'm consistent with the decimals. Also, if you recall, the formula for standard deviation is a square root of NPQ. Okay, so for this problem, it should be 500 times 0.65, Q is 0.35. Okay, all right. This computation, well, 500 times 0.65, we already did that to compute the population mean, which is 325. So I can simplify this by just putting 325 times 0.35 and square rooting the whole thing. And that should give me, I already have 325 written on it or displayed. So multiply by 0.35 equals square root, and that's giving me about 10.67, round that off. Okay, so I have the mean, population mean of 325 and standard deviation of 10.67. Oh, one thing I forgot to do is I should enter this in my memory cell. Okay, I already have 10.67. Actually, this is more accurate value, but I'll just enter 10.67. Oops. Hang on, let me start with the 325. 325. That's gonna go into my memory cell 1, STO1, and 10.67 STO2. Okay, let me verify this by clearing, and recall 1 is there, recall 2 is there. Okay. Alright, so let's go. Alright, so what we need to do now is do this probability computation. Okay. Remember, now we need to do what is called a continuity check. Okay, continuity check. If you look carefully, we are looking at starting with bar of 310, ending somewhere bar of 340. We want to include everything in between. Okay, this should be our leftmost bar, that should be our rightmost bar, and if you look carefully, that should be our starting point, so that should be 309.5. that's our continuity correction, and that should be 340.5. okay, hope you can follow that continuity check. So let me rewrite our problem one more time. That is going to be written as probability starting with 309.5, ending at 340.5. okay, and now this becomes our usual conversion to Z. Okay, and Z is going to be our usual formula. Let me go to the side. The Z of 309.5 should equal 309.5 minus the mean was 325 divided by the standard deviation of 10.67. okay, let's put that in the calculator. Okay, 309.5 minus, recall 1, remember I already stored that number in the memory, equals, divided by 10.67 is recall 2, equals, I'm getting about negative 1.45. okay, so that's our first Z value. Alright, then another one, Z of 340.5. okay, and what you'll see is that this number will be almost same, just that we are not going to have a negative. okay, so but let's go ahead and do this. 340.5 minus 325 divided by 10.67. 340 minus, oops, 340.5, sorry, 340.5 minus recall 1 divided by recall 2. okay, again it's same, 1.45. okay, alright, so what we have here is actually a symmetric picture. Z of 0 in the middle, negative 1.45 and 1.45. That's the area that we're interested in finding. okay, hope you can see that is going to be area of 1.45. that's only one of these, actually half of what I want, so the actual answer is going to be 2 times that. okay, hope you can see why I have this double. okay, so we can 2 times go to our chart of 1.45, 1.4 cross 5 is 0.4265, 4265, which is 2 times 0.4265 equals, I'm getting the probability of 0.853. okay, Alright, so what this result is saying is that there is about 85.3% chance that between 310 and 340 out of 500 of those Arctic tern will be found to have those band or what tagged. And again, this does not say that about 85.3% of the birds will survive. No, this does not say that. Okay, again, there's this probability that between 310 and 340 will succeed in their migration. Okay, that's it.